So this question is nasty because if you don't realize that it's partial fractions, there are really nasty ways to derail this question. And I didn't anticipate students doing that, but then upon reflection, I don't know why, because we studied so many different techniques in this chapter that it would be quite logical to try a variety of things on this. So but anyway, I hope that won't happen on this year's exam, but you never know. If it does happen, you know, if you get stuck, come up and ask me, because if I see that you're doing something logical and getting stuck, I'll just give a hint to the whole class. But this was meant to be partial fractions decomposition. And so we go ahead and start off our partial fractions. And if this happens to be 2014 and you're listening to this, I had some really useful suggestions from people in my class this year on how to handle these, and I liked it better than the way I was doing it. So one way you can handle this is to throw in x equals -4, which gets rid of that piece, right? So nice if you get rid of that piece, because then you say b times -4 equals, and then you could say 9 times -4, which is -36, and that's not too hard to do. And b has to equal 6, and that's quite a bit less algebra than I normally use to do the same kind of problem. Now this little shortcut, I kind of call it a shortcut because usually you try to match coefficients, and this is shortcutting that process, and it's totally valid, but sometimes it fails and sometimes you have to go back to matching up coefficients. But this little problem is pretty simple, and so we don't have to. 4a is equal to 12, a is equal to 3, short and sweet. We get the correct coefficients there. Let me go ahead and figure out what's going on. We should make note that there's a 0 at x equals 0 and a 0 at, where else? -4, right? And neither of those are in our domain, so we're good to go. Good. A is 3. And b is 6. And that was the hard part. If people got this far, they didn't get really jammed up on average. So it's 3 natural log of x from 3 to 2. You don't need the absolute value bars only now because it just turns out that we don't need them. Alright, so we go ahead and say 3 natural log of 3 minus 3 natural log of 2 plus 6 natural log of 7 minus 6 natural log of 6. And when you don't mess up, it's actually a really easy problem. But it's really easy to mess up. And yeah, so sorry about that. And well, I guess who should I be apologizing to? Last year's class. And hopefully you see it for the simple problem it was intended to be. Okay.